Hey everybody, I hope all is well. So today I was going to show you something that'll probably help with a lot of your projects. And that's going to be categorical independent variables. Oh yeah, I also figured out how to show my face on the screen, which maybe will be a little bit more exciting for the videos. So this is basically the same regressions we ran last time, which was a regression of coronavirus deaths based on how many cases they had, and we saw that was obviously really important, which makes sense. We also tested down here whether like the wealth per person in a country matters, and it turned out it didn't that much. We kind of came up with different reasons why it could help or not. But today I'm going to talk about categorical independent variables. These are commonly known as dummy variables. I have a habit of calling them dummy variables just because that's how I learned, but your book calls them categorical independent variables. And a lot of you guys expressed interest in doing something with categorical independent variables before your project, for the project draft. And so right here, I created a categorical independent variable. Let's see if I can make this a little bit smaller so I don't lose ya. There I am. Hello. So let's take a look at just what the definition of this variable is. So today we're going to actually use cases as an as our main dependent variable, because we kind of already analyzed number of deaths last time. And so today we're going to use cases as our independent variable of interest. Our dependent variable of interest, what causes cases. And so we'll look at GDP per capita again to see if that influences cases in any way. But the main reason for this lesson is implementing a categorical independent variable in Excel. So the way to think about any categorical independent variable is that it's like the answer to a yes or no question. Like oftentimes the variables we looked at are what I'd call continuous independent variables. This is a GDP per capita number. It could take like a bunch of different values in positive numbers, or probably not negative, but 0 to a really high number. And it can like vary continuously. But categorical variables aren't like that. Like a common categorical variable would be maybe you're looking at the instance of a certain disease across different populations, and you think that that disease is more common amongst the males. Well, whether an observation is male or female is a yes or no question. Is this person in my data set a male? That's a yes or no question. When you do yes or no variables in statistics, you use 1 as yes and 0 is no. That's the easiest way to do it. So I've created a variable called first to get. And I basically just found all the countries that reported their first coronavirus case on January 31st or before that. So these are countries that got cases relatively early. For example, Australia had a case relatively early. Of course, we know that down here, China was basically where it all started and where you had a lot of cases really early. Well, if a country got cases earlier, then it's been spreading in that country longer, and we'd expect there to be more cases at the time I collected this data. This isn't exactly up to date. I think I collected on about March 23rd or 24th when I made the last video. But so that might be a really good determining factor in how many cases a country has, is whether it was one of these first to get countries. Now, really a better way to measure that might be something like days since first case, but that's a little bit trickier to collect. So oftentimes when you have a variable like this would be the good version of the continuous variable, but it's really hard to collect. You can try to think of a way, like a quick and dirty way to do that with a dummy variable or a categorical variable. And that's what I did here. So did this country have a coronavirus case on January 31st or before? That's a yes or no question. If I have a 0 in here, then the answer is no. If I have a 1 in here, like for China, then the answer is yes. So let's go ahead and run a regression with that variable. So we're going to do data analysis, regression. I have it preloaded, but I'll clear it out so that it should look like what you see when you open it. So this is kind of what the default looks like right here, except this would be blank too. So this is what it should look like when you open this in data analysis in Excel. So today we're going to use cases as our dependent variable. So I'm going to click cases, shift command down. And then for our X range, we're going to have two independent variables, GDP per capita and this first to get variable that I just made. So you just, once you're doing the regression, you just treat this like any other independent variable. So I'll just go over those. So notice right here, I go from D to E because I'm highlighting that rectangle like we did in the last multiple regression video. So I have labels. I included labels, which is always a good choice. Now we'll do output range. So you'll have to click that because I think I clicked that already, but yours probably loaded to new worksheet. Let's put it down here because like I explained last time, then if we have like a bunch of regressions like this, we can compare them. We are using a different dependent variable this time, so we might not want to directly compare to those above regressions, but I'll just keep it there so that you kind of have like a history of what we've done with this spreadsheet. And then I'm ready to just push OK, I believe. Uh-oh. Output range missing. Okay, there. Oh, you guys saw me do that like 1,000 times. So let's go re-highlight our independent variables. What I did is I didn't take my cursor out of this box when I went to click my new output range place. So I went and clicked down here without moving that cursor, but I got to go move that cursor right here. Click right here. Now we should be ready to go. Okay. Sweet, we got some results. Notice our R squared is much smaller now because up here we were looking at cases and deaths. Like cases are going to totally be a good predictor of deaths and explain a lot of the variation. So we got a big R square. Now we're using GDP and then just this 0, 1 variable on cases. So it makes sense that we're explaining a lot less of the variation. So first let's go to our slopes because we kind of like to interpret those first. So just a reminder for this GDP one, our best estimate is that when GDP per capita increases by 1, coronavirus cases in a country increase by 0.0017, holding this new first to get variable constant. And actually, I'll explain this further a little bit more, how we can hold that constant, because it's kind of weird because it's this 0, 1 variable. I'm going to do that in the next lecture. But now let's look at this first to get variable. This is kind of interesting because I would say when first to get increases by 1, coronavirus cases increase by an average of 15,500 in a country's, on average in my data set, holding GDP constant. But that's kind of weird to interpret it that way because notice when I say increases by 1, well, there's only two values for that variable, 0 and 1. The only way it can increase by 1 is from going to a country that was not one of the first to get to a country that was first to get. So a simpler interpretation would be something like holding GDP per capita constant. On average, countries that were the first to get have about 15,500 more cases. Now, of course, we want to find out, is this a new first to get variable statistically significant? Yeah, it's really statistically significant because that has a p-value 0.000000001586. So that's a tiny p-value, tiny probability of observing this estimate when there's actually no impact of being one of those countries. Now we go to our R squared. This model with GDP per capita and this first to get variable explains 25% of the variation in coronavirus cases across countries. Now, if you think about it, at first I said that's kind of small, but actually that seems pretty substantial when you consider, well, one of our variables is not statistically significant, as we saw before. Almost 100% chance of getting that estimate in a world where the truth is 0. So yeah, that's fine. Like that probably has no impact. And we saw that before with deaths too. So basically this first to get variable is explaining all by itself, even though it's only zeros and ones, is explaining 25% of the total variation in the coronavirus case data. Which is kind of like a scary story if you think about it, because what that means is that at least 25% of the variation in coronavirus cases is just when it showed up in a country. So that's it for today. Next time I'm going to show you, I'm waiting for a whiteboard from Amazon right now. Thank you, Amazon. You're awesome. And I'm going to use that next time. I think there's some other cool stuff in that video that you might appreciate, some new surprises maybe that you can look forward to, because we're going to try to spice things up from now on, because we're getting a little cabin fever here, right? All right, I'll see you guys later.